So here's the brief video that I'm going to share with you that is based on the Unit 2 review, which is due tomorrow at the beginning of the hour when I will be collecting your packet, and I will also be collecting the in-class activity that we worked on yesterday. So in questions 1 through 5, I've already gone through and filled in the answers for the definition of energy, the definition of potential energy, the types of potential energy, the first law of thermodynamics, and the major difference between work and dissipated energy. Now I'm going to take a few minutes to go through the couple of problems, and then we should be done. So, in this case, a rocket fires its engines and starts to move deeper into space, and I'm telling you that the rocket is the system. And there's a couple of things that we need to be aware of. Initially, the velocity is equal to 0, so it's not moving, and then finally the velocity is greater than 0, so that it is moving. So in this case, we're going to start with the fact that the rocket has a bunch of chemical energy, and it has chemical energy because in order to fire its engines, it has to use its fuel. So then we're going to say that the rocket has kinetic energy, but it also has some chemical energy left over, in large part because, as far as we are concerned, the energy of the system, or the rocket is still moving, rather. So when I go to write my equation here, I'm going to say that I have chemical energy equals kinetic energy plus some leftover chemical energy. Now, the next one, the ninja slides down the rope and gets rope burns on his hands, and I also tell you that the ninja and the rope are the system. So in this case, in this particular scenario right here, I have ninja and rope, and the ninja is sliding down the rope, and the ninja is getting rope burn on his hands. So initially, the ninja has a velocity of 0, and then finally, the ninja also has a velocity of 0. So originally, he's kind of standing and he's hanging here by this rope. So he basically initially just has gravitational energy. And because he is getting rope burn on his hands and he's not moving at the bottom of his system, he also gets dissipated energy through the heat buildup in his hands to cause the rope burn. So here we have gravitational energy equals dissipated energy. And one of the things to remember when you're looking at that is the fact that the energy changed within the system. It didn't leave the system. In number 8, we have a pirate pushing a car, which starts at rest, and the car is the system. So because the car starts at rest and it's not moving, it has no energy initially. But the car is moving at the end, and it's moving, and because it's moving at the end, it has kinetic energy. So in this case, the second half of our equation is going to be equals kinetic energy. Well, if it doesn't have energy to begin with, that means that the pirate had to do work on the car. So that tells me pirate is doing work on the car to get the car moving. So my new energy equation here is going to be initial energy plus work equals kinetic energy. And then lastly, we have the pirate pushing a car which starts at rest. The pirate is the system, and then eventually the car is moving. But because the pirate is the system and not the car, this is something that we need to pay a little bit closer attention to. So in this case, initially, the pirate's pushing the car which starts at rest. Well, where does the pirate get the energy from? Well, the pirate gets the energy from the food that he ate prior to pushing the car. So that means that the pirate started with chemical energy, and then he gets the car going, and at some point the pirate is going to have some kinetic energy, so he's going to be moving. He's not going to be moving very fast because he can't get the car going very fast. So where is the majority of the pirate's energy going to be going? Well, it's going to be going into the car. And so now I have 1, 2, 3 blocks of energy for my arrow going into my car. I still have the one remaining block of energy for the kinetic energy that the actual pirate's moving with. And now I need to write my equation. So I'm going to start with E chem minus work will equal a small amount of kinetic energy. And there you have it. That's the answer key for this particular worksheet. I hope that it helped and you're going to be more prepared for the test tomorrow.